So once again, welcome to School Coaching Point. So this is the third video of complex number. So in the previous video we have discussed the representation of complex number. So a complex number can be represented in the form x plus iy. So any number which we can write in the form of x plus iy is known as the complex number. So we have already discussed in the first video. So where x and y, these are the real number. X, y are real numbers. And this x is known as what? Real part. This is the real part. And this is known as the imaginary part. Imaginary part. So y is known as the imaginary part because y is attached with I. And what is the value of I? I is equals to root over minus 1. So we have already learned all these things, representation of complex number. One more thing we have learned, the conjugate. So x plus iy is a complex number. So what is the conjugate? It's x minus iy. So conjugate of x plus iy is x minus iy. Similarly, if x minus iy is the given complex number, then what is the conjugate? X plus iy is the conjugate. So if plus sign is given, then conjugate should be in minus. If minus sign is given, then conjugate should be plus. So we have already discussed in the previous video. So today we will discuss eigenplan. Eigenplan means how can we represent a complex number in the xy plane. So this thing we will learn today. So eigenplan means is the combination of x and y plane. So the representation of any point in the coordinate plane we have already learned in class 10. So today we will discuss how to represent the complex number in an xy plane. So we know any complex number can be represented as z equals to x plus iy. So where x is the real part and y is the imaginary part. So in eigenplan, so eigenplan is the combination of x-axis and y-axis. In x-axis we should represent the real part. So in x-axis we should represent the real part. That's why x-axis is known as real axis, because the real part of any complex number we should represent in the x-axis. So x-axis is known as real axis. Similarly, the imaginary part of any complex number can be represented in y-axis. So imaginary part should be represented in y-axis. That's why it is known as imaginary axis. So x-axis is the real axis and y-axis is the imaginary axis. So simply just remember real axis y, because the real part of any complex number we should represent along x-axis, and the imaginary part of any complex number we should represent along y-axis. So here z equals to x plus iy. This is the complex number. Suppose x equals to 5 and y equals to 6, then the complex number becomes 5 plus i6. So in 5 plus i6, 5 is the real part. So this 5 we should represent along x-axis. So we should make the division 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And while you're making the division, the gap should be same, the gapping should be same. So since the real part is 5, so 5 should be represented in x-axis. So 1, 2, 3, 4, 5. This is the point 5. Then after that, what is the imaginary part? 6. So 1, 2, 3, 4, 5, 6. So it is 5 and 1, 2, 3, 4, 5, 6. This is the point. So in real part, 5 is there, so 5 should be represented in x-axis, that means in the real axis, 1, 2, 3, 4, 5. And 6 is in the imaginary part, so 6 should be represented in y-axis, that means in the imaginary axis. So 1, 2, 3, 4, 5, 6. So this point, this is the point Z. That means this point is represent the complex number Z. Z means 5 plus I6. So in 5 plus I6, from the coordinate plane, we can clearly mention that 5 plus I6 is nothing but the order pair 5 and 6. If 5 plus I6 is the complex number, that means the representation of 5 plus I6 is nothing but the representation of the order pair 5, 6. So this is the point 5, 6, where 5 is the real part and 6 is the imaginary part. Taking one more example, suppose 2 plus 3i. So we should represent 2 plus 3i. So what is the technique? Since 2 is the real part, this is the real part, and 3 is the imaginary part. So real part should be represented along x-axis, that means in the real axis, and the imaginary part should be represented in y-axis, that means in the imaginary axis. So what is the real part? 2. So it's 1, 2. And what is the imaginary part? 1, 2, 3. So this is the point 2, 3. So 2 plus 3i, representation of 2 plus 3i is nothing but the representation of the order pair 2, 3. So where 2 is the real part and 3 is the imaginary part. So after that, we should know one more concept, finding the modulus of a complex number. So what do we mean by modulus? Suppose this is the Argand plane. This is the Argand plane, and this is real axis, and this is imaginary axis. And p x, y is a representation of a complex number. So p should be here x plus iy. So p is x plus iy is a complex number, and the representation of x plus iy is p bracket x, y. This is the order pair. And this is the point P, that means this perpendicular distance should be x, this perpendicular distance should be y, and this perpendicular distance should be x. If it is x, then this distance should be also x, means px comma y, it means y means the perpendicular distance. This is the perpendicular distance, and x means this is the perpendicular distance from y-axis. Now we can find out the distance of the point P from the origin. So here POM, suppose this is the point M, POM is a right angle triangle. P means we have already know, it's x comma y, representation of the complex number x plus iy. So OP means the distance of the point P from the origin O. So how can we find out the value of OP? Since it is a right angle triangle, so using the Pythagoras theorem, OP equals to x square plus y square. So OP square equals to x square plus y square. So hypotenuse square equals to base square plus perpendicular square. So x square plus y square. So OP square equals to x square plus y square. So from here OP equals to root over x square plus y square. That means OP is the distance of the point P from the origin O. And this distance is known as the modulus of the complex number. So OP is the modulus of the complex number P. So modulus can be represented by this symbol. So here modulus of x plus iy is equals to root over x square plus y square. So this is known as modulus. So modulus of any complex number is nothing but the distance of the point P from the origin. So taking one more example, suppose 2 plus 3i, and my question is what? Find the modulus of 2 plus 3i. So what is the modulus of 2 plus 3i? It is the distance of the point 2 comma 3. It is the distance of the point 2 comma 3 from the origin. So how can you find out the modulus? So x square plus y square. So what is x? 2 square. Y means 3. 3 square. So it's 4 plus 9. It's 13. So modulus of 2 plus 3i is equals to root over of 13. So you just simply remember modulus means it is the distance of the point P from the origin. So once again repeat the topic, eigenplan. So eigenplans mean the plan in which we can represent any complex number. So eigenplans is the combination of x-axis and y-axis. It is also known as xy plan, where x-axis represent the real axis and y-axis represent the imaginary axis. So in any complex number we know there are two parts. One is the real part, another one is the imaginary part. So the real part we should represent along real axis, and the imaginary part we should represent along imaginary axis. This is the key point you should remember. Then the last topic is the modulus. Modulus means the distance of any complex number, distance of a point from the origin. The distance of a point from the origin is known as the modulus of the complex number. So distance means it should be the shortest distance. finding the modulus of a complex number, it's very easy. We should know modulus should be represented by root over x square plus y square. So modulus means root over x square plus y square, where x is the real part, y is the imaginary part. So 2 plus 3i, so what should be the modulus? Is root over 2 square plus 3 square. It's 4 plus 9 is 13. So once again, thank you for watching the video. If you like the video, kindly subscribe my channel and press the bell icon for the notification of video.